Find null space of A for the following matrix. So we got a matrix A here. We need to determine its null space. That means we want to find all vectors x, okay, all vectors x, such that when we apply A, they are mapped to 0 when they go to 0, okay, ax equals 0. So we are trying to find this. That means we want to solve this matrix system A0, where A is this, okay. So the augmented matrix, so we write 1, 5, -4, -3, 1, 0, 1, -2, 1, 0, 0, 0, 0, 0, 0, and that equals 0. A x equals 0. And this is already in row echelon form, because 1 pivot all 0, 1, that's the pivot 0, and there are no pivots. So we got pivot here, so let's say x1, x2, x3, x4, x5. So this one is free. So x1, x2, x3, that's free. x4, that's also free, no pivot. x5 also free. Okay, now then from this equation, I mean this 0 equals 0 is good. So this equation, the second row, I'm working backward. So here there is no information. From the second row we get 1x2 minus 2x3 plus 1x4, just x4, plus 0 equals 0. And we know that x3 and x4 are free variables, so we can solve for x2. So x2 equals, move these over, 2x3 minus x4. From the first row, now we get 1x1 plus 5x2 minus 4x3 minus 3x4 plus x5 equals 0. And we know that x2 is given in terms of x3 and x4, so we're going to write that. x3 is just x3 free, x4 is also free, x5 is also free. So this one is basically x1 plus 5 times x2. So this is x2, so let's multiply by 5. So 5 times x2 is 10x3 minus 5x4. Okay, 5x2, pretty much I multiplied x2 by 5, minus 4x3 minus 3x4 plus x5 equals 0. So we are solving for x1, and x3, x4 and x5 are free variables. Okay, so let's move. We can combine. If you look at closely here, x3 can be combined, and x4 can be combined, and let's move over. So x1 is equal to 10x3 minus 4x3 6, negative 6x3, negative 5x4 minus 3, negative 8, so positive 8x4, and here is x5, subtract x5 from both sides. So we got x1 here and x2 here, x3, x4, x5 are free, so null space, we write just null A, that is null space of A is in fact just all the x's, that we got 5 components, x4 and x5, so collection of these. Okay, I mean this is just that is equal to x1 is found to be negative 6x3 plus 8x4 minus x5, x2 is found to be 2x3 minus x4, x3 is just x3, it's free variable, x4 is just x4, x5 is just x5. So we want to write this in parametric vector form. So we got 3 variables, so I want to take x3 factored out and I'll have a vector, plus I want to factor x4 out and I'll have a vector, and I want to take x5 factor out and I have a vector. Okay, so x3 negative 6x3 negative 6, 2x3, 1x3, no x3, so 0 0. X4 there, 8x4 8, negative x4, so negative 1, no x4, so 0. Here is 1, there is no x4, 0. x5 there is negative x5, means negative 1, no x5, none, and 1. Okay, so these type of collections, they are all in null A, and x3, x4, and x5 are free variables. That means they can be any real number. So this one we can write in this way. This is same as span of these 3 vectors. So these are the linear combination. I mean, what we wrote here is a linear combination. So we can write that as span of these 3 vectors. Negative 6, 2, 1, 0, 0. That's first vector. Okay, so that's 1 comma, second vector is this 8, negative 1, 0, 1, 0, comma, negative 1, 0, 0, 0, 1. Okay, we may leave here. Okay, this is a linear combination of these 3 vectors, which is same as span of these 3 vectors. That's the null A for the given matrix.